Yes. Sorry to interrupt you. I just
Yeah, no,
it might be helpful.
I'm recording it now because it's very important that this is all kept, because people will want to look at it later, because they're all going to ask the same questions. Why isn't anybody speaking up about physics not being able to explain biology? Well, they are.
Yeah.
But those voices tend to get squashed by the other people.
Yeah.
Who don't dive into the difficult questions. They scout round them.
Right, okay.
That's the real problem. So what I do is I get books like that. Now that's a pamphlet written by Jehovah's Witnesses, basically saying there's no way on earth that physics explains all this genetics. And it doesn't. The laws of physics are never mentioned in a biology book. Never mentioned. But unless somebody says that, the public don't notice it.
No.
And they think, oh, well, it's all just too complicated, so that's why you teach it in separate departments. But the fact is that if it's explained correctly, so I explain it like this. My bones obey the laws of physics. They behave as levers.
Yeah.
I fall over under the influence of gravity.
Yeah.
And my molecules are held together by electromagnetism.
Right.
But what those molecules then consequently do, form DNA and cells, is not explained by electromagnetism. The fact that my bones can evolve into a dog's paw, a bat's wing, or a whale's flipper, or mammals, all using the same bones, is not explained by any physics. And it would be ludicrous to go to the Large Hadron Collider and say, well, haven't you solved the problems of evolution yet? But people say, well, that's ridiculous. It's not ridiculous because they study the same matter that evolves into animals and plants and fungi.
Right, okay.
So it's a very sensible question to say the study of physics, chemistry and biology and genetics is the study of the same matter. True or false question?
Yeah, true.
It's true. There isn't anything else. There's no other matter besides the elements. There's some exotic matter which you can make, but it disappears in billionths of a second. So all the physical universe is made of the same matter, and that's just true. Now it gets very exotic in neutron stars and things like that, but in most of it just makes stars and solar systems and snowflakes and squids. That's all the same stuff.
Yeah.
If it's all common, it must have a common set of rules. Now that's logical.
Yeah.
And those rules must be self-consistent, like the periodic table is self-consistent information. Yeah. The standard model is not self-consistent information. That's the problem.
Right, okay.
So when the standard model is self-consistent, and that has now been done, it must be shown to be self-consistent with the periodic table because it's all the same matter.
So when you talk about the standard
model,
what is that now? What is the standard model now?
Right. If just look it up on the computer, what's the standard model?
Yeah.
It's basically the periodic table of the little particles, basically bosons, which are the particles which transmit interactions.
Right.
And their partners. But the problem is it's not complete because it doesn't contain gravity.
No.
So that's the deep problem with it. And it's not symmetrical and sequential like the periodic table.
Okay.
So if the material underneath the periodic table isn't in a sensible pattern, it doesn't make sense that the periodic table is in a sensible pattern. It's all sequential. So once it's explained like that, anybody can understand it.
Yeah.
The periodic table is all in order and there's nothing missing. The standard model is not in order and there is something missing, and that's gravity. You can't have a model of nature that doesn't have gravity.
Right, okay.
So that's the big problem. And the Unzicker, remember that guy Alexander Unzicker? He's done some very good videos criticizing the standard model, saying it doesn't make any sense whatsoever. But he gets a really hard time from the physics community.
What's his YouTube channel? Do you know?
Alexander Unzicker. Let me think. Do you know? I don't know, Darren, actually.
How do you spell his last? Unzicker?
Yeah. Unzicker.
Yeah, Unzicker's Real Physics.
That's him.
Brilliant.
So if you look at his video on the standard model.
Yeah, I will do.
It's very, very good. I've emailed him quite a few times, but he never replies to me.
Right. Yeah, he must be sick of the grief he gets.
Yeah. Yes. Whereas I don't get any grief, I get silence.
Yeah.
I used to get grief.
Yeah.
I used to get hate mail.
Right.
That contained no science whatsoever. It was just abuse.
Wow. Okay.
So I used to keep all those. Now I don't get any abuse. I just get silence. So
right.
something's changed.
Yeah, I don't know whether that's a good thing or what, but
well, to be honest, now I've got so much confidence now that I didn't have before, because I've been memorizing it and testing myself again and again and again and again. I test myself with whoever will question me.
Yeah.
And at the minute, I haven't had anybody ask a question that I couldn't answer clearly and simply.
Yeah.
And consistently with all the other answers. So my confidence is sky high that it must be correct, because if you've got a version of the standard model which is self-consistent and consistent with the periodic table and consistent with the eightfold way, which is basically how particle physics is all laid out in pairs and triplets, and consistent with the construction of the elements, which is very important, that where electrons sit is based upon the first two prime numbers. It's all self-consistent. And the formation of helium in the sun is all based on pairs and triplets. And helium is the first composite element made of smaller elements, and it has 4 nucleons, and 4 is the first composite number made of smaller numbers, primes. That's not coincidence.
No.
Just no way is that coincidence, that all those things fit together. And once you keep on fitting it together, for students, they absolutely love the consistency, and they can see it all. But when you do that for a physics professor, they all do the same thing. They walk away in silence because they feel completely flummoxed by it. That there's a perfectly ordinary person fitting together the whole of science and solving all the big problems with physics, and they're not expecting it. So it's like suddenly winning the lottery. Your brain just goes, no.
Yeah.
And then your brain goes into a paradox, with half of it saying this is all logical, the other half saying this cannot be true, and you battle it out. You've got to give logic the amount of time it needs to win. That's why you have to keep saying it again and again and again, and keep looking at the evidence again and again and again. This must be true. This must be true.
Yeah.
But as soon as you make a claim that you've got a version of the standard model which is symmetrical, people don't want to look at it. the thing at
Right.
simplest.
Okay.
Instead of looking at it, and it either is all symmetrical or it's not. It either is consistent with the periodic table or it's not. It either is consistent with prime numbers or it's not. So it's very, very simple.
How can we give it to them then without without scaring them off? You know what I mean?
Well, that's what I need to find out. So it's a matter of approaching it step by step by step, not giving them the model too soon.
Yeah.
But just let them almost find out for themselves. If you put the bits which are all the same pattern in front of them, their brains will say that's all the same pattern.
Right.
So if they work it out for themselves, when they see the standard model and that is in the same pattern, their brain is already expecting what it's going to see, so it doesn't get a shock.
Yeah.
I think it's going to have to be something like that. But basically what it needs is publicity.
Yeah.
So the public can make up their own mind. What they do, 99% of people don't have the confidence to validate anything to do with physics by themselves, even though there's nothing more too complicated, as long as they're shown the right evidence. So that book, which you've got by Hilborn, has all the right clues to guide somebody to a new way of thinking.
Yeah.
Because he says in the book, physics is not appropriate here when he's looking at chaotic systems.
Right.
And then he also says that chaos is universal. It shows up in every field of science. Therefore, it must be the link. What he fails to recognize is that it's a new layer of laws on top of physics, which nobody suspected were even there.
Right. Okay.
You wouldn't guess in your wildest dreams that there would be any relationship between biology and physics based on the chaotic behavior of matter. It doesn't seem to make any sense at all. But the chaotic behavior of matter is as experimentally provable as classical physics. So you have to see it as science. What you can't say as science is, what people do is that they say that chaos is part of classical physics. And that's the mistake.
Right, okay.
It's a huge mistake. Chaos is now described systems which are sensitive to initial conditions. But that's the wrong description. The description should be systems which have an infinite number of possible outcomes. Classical physics is systems which have a single possible outcome. So those two give you what you need to explain a snowflake, which all comes in the same six-sided pattern, but it has an infinite number of details. A human face, which all come in the same pattern, but have an infinite number of possible outcomes. So you've got physics, the fact that your bones behave as levers, and then evolution, which comes from the interplay between systems which have chaotic parts and physics parts, classical physics parts. And it's that interplay between the parts which shows up as cellular automata, which is in the book A New Kind of Science by Stephen Wolfram.
Right.
So that's very, very important, that you can't look at the parts and see what they're going to do. Because when they interplay with each other, you get human faces which cannot be predicted by any science.
Right, okay.
That is now part of science. So you can't look at the smallest bits in the standard model, the fermions and the bosons, which are the two kinds of different particles. Ones that have properties and ones that transport properties, if you like, carry the properties to other particles. So
have you seen the new Sabine Hossenfelder video
yeah, I watched it last night.
on particles? Yeah. So I don't know if we're going off topic here a little bit, because she described, didn't she, like classical particles and quantum particles.
Yeah, so let me just
What?
tell you what that actually means.
Yeah. What's the difference? Like,
Right. A classical object is something which has physical properties.
right.
That means it bounces off other objects. So
Yeah.
if you say it's got physical properties, therefore it behaves as a classical object. Quantum entities are not objects because they have no physical properties. They only have
Right.
mathematical properties.
Right. Okay.
So that's very, very important, that space has no physical properties, and yet it moves the solar system around, and it moves magnets around. So what general relativity is a relationship between things with physical properties and space, which has no physical properties, but has mathematical properties, which cause the change in geometry of physical properties and changes them into spheres.
Right.
And that's very important, that you see it for what it is. The relationship between a magnet and the space outside it is the same as the relationship between the Earth and its gravitational field. The Earth also has a magnetic field, which is a property of the space outside the magnet, which has no physical properties, only mathematical ones.
Right.
So quantum particles are not little units of any substance.
Right.
They're little units of energy which have mathematical properties. So positive and negative are mathematical aspects of quantum entities. And that's a true or false question.
Yeah. True.
True. Because positive and negative have no no physical parts. Now you could say left and right, but you can't say to a child the difference between left and right in physical terms is the left and right, because left and right define each other. You can say that physical stuff comes into mathematical properties, which are equal and opposite, left-handed and right-handed molecules. But again, you're using mathematical properties to describe physical structure.
Right. Okay.
Which now is valid, but under the old way of thinking, that's not valid.
Right. Okay. And why isn't it valid then, Peter? What's in the old way of thinking?
Because in the old way of thinking, you've only got 3 dimensions of physical matter.
Right.
Therefore, you cannot distinguish between left and right-handed stuff.
Right.
If you're saying there's mathematical properties, you then have to have that in the same pattern as the standard model, which has mathematical properties, two triplets of leptons, 2 triplets of quarks, 6. So if you're outside a box, it's just got 3 dimensions. If you're in the middle of the box, how do you distinguish between the left and right, the front and the back, and the top and the bottom?
Yeah.
Yeah. So you can use mathematical properties of being positive and negative, and you've done it.
Right. Okay.
But previously, you weren't using mathematics to describe physical stuff. You were saying it just has physical properties, which quantum mechanics doesn't have any physical properties. It only has mathematical ones. And Max Tegmark states that very clearly in his book. They have no intrinsic physical properties. They are not little units of substance. They are units of energy. So that way you've distinguished between quantum entities and classical bodies or objects. You can call because the object has physical properties, it bounces off other objects, even though when it bounces off it, there is no physical contact with anything at the atomic scale.
Right.
There's just one magnetic field bouncing off another magnetic field. There isn't a little unit of substance bouncing off another unit of substance, because there aren't any units of substance in the quarks and the leptons, which make up matter.
Right. Okay.
So again, it's a relationship between the space in between the matter bouncing off other bits. And the quantum entities do not have intrinsic substance or physical properties. Electron has no intrinsic mass. It gets that from the Higgs boson, which brings that mass along to it. And it has no volume. And volume and mass are the two defining properties of physicality.
Right. Volume and mass.
Yeah.
Volume, I'm going to write that down. Are the two defining properties of physical...
Of physical matter.
Volume and mass.
Yeah.
Are the two properties
which define physicality.
Right, okay.
So what I would say is the smallest unit of or system of matter would be a proton, which does have volume.
Right, okay. So that means it's a physical property.
You could say it as a physical property, but the volume doesn't come from the three quarks inside it. It comes from the fact that the three quarks have an interplay with the antiquarks and the gluons that stick everything together. So the mass of the proton, more than 90% of it, doesn't come from the quarks, which we say build in the physical matter. So if 90% of the mass of the proton is not the bits that make it, give it physical qualities, then we've got to redefine our language that we're using, because when the language, like the word particle, infers a tiny dot of substance,
right,
when there isn't any.
Okay.
Physical properties of matter come from the fact that matter both attracts and repels in units of energy. And if units of energy attract and repel each other, they hold themselves together and hold themselves apart at the same time, giving volume.
Right, okay. Okay.
So that now makes sense, because there's no contradictions in the language. And I'm
No.
not using the word particle. So Sabine Hossenfelder uses the word classical and quantum particle.
Yeah.
But the particle is the wrong word.
Right, okay.
If you said the quantum entity and
Yeah.
a unit of energy, you haven't gone into contradiction.
Right, okay. Okay.
So that makes a lot of sense. So the real problem is that there is nothing in classical physics which can describe how a bone, which behaves as a lever, evolves into all the things it does. There's nothing in quantum physics which describes how a bone evolves into all the things it does.
No.
There is, if you put together classical physics, quantum physics, and chaotic physics as a triplet of rules, which do then explain how order in systems comes out of chaos, you've done it.
Right, okay.
You've got enough rules to explain the emergence of snowflakes, molecules, and biological systems. So chaos shows up in biological systems. Classical physics shows up in biological systems, but only the fact that they're physical systems, not the fact that they're doing biology.
Right, okay.
But a combination of quantum, classical, and chaotic physics can explain biology.
Right, okay.
Now, I've said that to this German guy, and he keeps saying, I can't understand what you're saying to me.
Okay.
So there's a mental block.
Yeah.
That you now have enough rules to explain the systems of matter that we observe without contradictions. And you only need 3 to get everything else, because you only need 3 of anything at base to get everything else, whether it's light or 3 different quarks, 3 different parts of the atom.
Right. Okay. I've just been. I'm following someone on Facebook, Professor Bruce Lipton. Have you heard of him?
No, I've not, but I'm going to write him down.
Yeah, I've just downloaded the first chapter of his book, The Biology of Belief.
Right.
And I've been reading the first, and he's compared the human cell to the to human beings. I'm not going to explain it. I can send you the link to the first chapter.
If you send.
Oh yeah. Yeah.
Read.
I had been fascinated by the idea that considering cells as miniature humans would make it easier to understand their physiology and behavior.
Yeah, that's absolutely true, because there's a very good book by Geoffrey West. I'll just get a drink down.
Yeah.
A good book called Scale, which basically says that all systems, whether they're a cell or a human business, a company, behave to the same rules, which they do.
Yeah.
So they behave to the laws of physics, and they behave with cellular automata, which means they're a little entity which has some rules of how it engages with other entities, and the interplay with those rules causes action.
Yeah, and I like he said something about how cells can be observed to protect themselves.
Yes.
Yeah, and that's what we do as human beings, don't we?
Absolutely. Yeah. Survival of the self.
Exactly.
That's what stars do. They keep themselves in a state of being as long as they can. So we say the life and death of a star.
Right. Okay.
It's not a biological system, so it's not complex, but it is still a system of the same matter as biology, and it keeps itself in a state of being as long as it possibly can.
Right. Okay. And
sorry. No.
When you say a star isn't complex, can you explain that to me, please? Because I imagine stars to be very complex. You know what I mean?
Compared to a cell or a snowflake, they're not complex at all.
Right. Okay.
Because they don't have chemistry.
Right. Okay.
So they're formed by a relationship between the gravitational interactions and the atomic interactions. And that's very important to see them as formed by the difference between the strength of the atomic interactions to the strength of the gravitational interactions, which is why they're so big, because it's the biggest difference. It's the difference between things which forms them, not the things themselves.
Right, okay.
So it's not the atomic structures or properties or the gravitational properties, it's the difference between them which causes the star to be what it is.
Right, okay.
So people don't look at things like that.
Yeah.
They look at them as one or the other. Are you male or female? You can't be one or the other. It's impossible. Nobody comes from a single parent.
No.
There is no such thing as an asexual human being. There are asexual animals that grow another animal identical to itself, like a hydra, but not in the case of human beings. Every human being needs 2 other human beings to make it. That's a true or false question.
Yeah, true, yeah. Right.
So it's clearing all these things up in language, which is really important, because human beings think in language.
Yeah.
Sabine Hossenfelder is using all the confusing language, which gets everybody, so you can't make any sense of it.
Right, okay.
So hopefully when I explain the difference between a classical object and a quantum entity in the right language, that one has physical properties and the other has no physical properties, just
No.
mathematical ones in terms of units of energy. So think of energy of the stuff, that of which the universe is made.
Energy equals that
of which the universe is made.
Of which the universe is made. Okay.
And think of mathematics as providing the governance of the energy.
Mathematics equals provides the governance. Of provides the governance. Of the energy provides the governance.
So the universe boils down to two things: stuff and rules.
Of the energy that drives the universe. Is that the correct?
Yes. So the rules are all mathematical.
Yeah.
The stuff is all energy. Fields of energy, waves of energy, units of energy.
Right.
And physical properties emerge out of non-physical energy.
Out of non-physical energy. Okay.
Yeah. So the physical properties are not there at the beginning. They all have to emerge.
Right.
So the physical universe emerges out of a universe which is purely mathematical. It's energy, but there's no physical properties, and it has non-physical or these ethereal mathematical rules which provide the governance of the energy. And what we do as human beings is work out what the rules are and then write them down and bring them into physical reality and then look at them.
Right. Oh, okay.
We don't invent the mathematics.
No.
That's the big thing. We don't invent positive and negative. It's already there on every battery in the universe.
Yeah.
It's got positive and negative parts. That's true or false. But that's not taught in any school.
Yeah, it reminds me of that Closer to the Truth video. Is mathematics discovered or
Invented?
Invented.
Yeah. So the fact that atoms come in positive and negative parts, which just means equal and opposite, because there are unequal and opposite parts, like odd and even, strong and weak nuclear interactions. The fact that the strong nuclear interaction is stronger than the electromagnetic interaction, so there's competition. But equal and opposite means fair. Fair competition is what drives economics. So that's
equal and opposite equals fair.
Yes, that's what fairness is in the human mind.
Right.
So the human obsession with sport is based upon fair competition.
Yeah.
The atom is based upon fair competition.
Okay.
So what holds the atom in a state of being is the fact that positive and negative fields of energy are equal and opposite. Right. And the strong nuclear interactions are slightly stronger than the electromagnetic interactions. And that's what holds, so it's fair competition.
Yeah.
And the human obsession with sport is mind-blowingly simple. It's fair competition. But Denise Hearn's book, the Myth of Capitalism, is all about, on the front, monopolies and a lack of fair competition. So a healthy economy is based upon fair competition. Not people like Apple who just buy up all the other companies.
Yeah. Right, okay.
So that puts things in perspective, is that you're looking at the connections between atoms, economies, human fascination with sport,
yeah,
the self-preservation of stars. So everything connects up to the same rules, fair competition.
Right, okay.
And fair competition, what that does, that improves the system. So sport produces better and better athletes.
Right.
And we're obsessed with it for no good reason, other than it improves the human system.
Right, okay. Oh, so there is a reason then why we're getting faster.
Yes. Yep. And there is a reason that everybody's fascinated with sport. Because if you say in language, what is throwing a shot put? It's throwing a lump of metal. That's your life. So that's reality. We're fascinated by it because we want to see who wins. But it has to be fair. We don't just want to see a big guy boxing a small guy, knocking him out every time. We don't want to see that.
Yeah, and in the steroids, isn't it? That's why we.
Yeah.
It's unfair if a few of them are just taking steroids.
Yeah.
Right. Okay.
What we love is a really close finish.
Yeah.
Closer the better. So everybody's going off Formula One at the minute because you don't get any competition.
Yeah. Well. Yeah. And it's gone too safe. There's not enough crashes as well. In my opinion.
Brutal that, Darren. Brutal. It's going to be more gladiatorial, is that what you're saying?
Yeah, exactly. Yeah. They're just too nice.
Yeah. Well, people don't mind boxing as long as it's fair.
Right.
And
Okay.
there is consent.
Right. Okay.
So the word consent, what does that actually mean? What it means is that the system has a choice. Now, all biological systems at base have something called random fluctuations. They flicker between one thing and another. This is how a snowflake is made.
Right.
And it settles on one thing, gets a choice. If a molecule gets a better choice, it takes it.
Right.
So freedom of human choice leads to the stability of the system. That's democracy.
Right. Okay.
The only thing is that democracy is now being bought by large companies in America.
Yeah.
So it's not democracy anymore.
No.
Your vote, and the same in England, if you don't vote for the winning party, your voice wasn't heard. But in Germany, it is. Everybody's vote counts.
Right. Oh.
Because you've got proportional representation.
Yeah.
So that's very, very important to see that what human beings are doing subconsciously. We watch sport subconsciously, but we all enjoy it.
Yeah.
But there must be a reason for that, and that reason must be universal, and it is.
Right. Okay. And this comes from the positive and negative.
Yes.
Right. Okay.
That forms the atom.
Right. The positive and negative that forms, and it's the relationship, isn't it, between the positive and the negative.
Yes. Equal and opposite.
Equal and opposite. Equal and opposite.
Yeah. Then the strong interactions, electromagnetic interactions, one is stronger, the other's weaker. One wins.
Right.
Which is why you need neutrons, which have more strong force, but don't have equal and opposite parts which repel each other. So I end up with more strong force binding it together, even though the protons are trying to blow it all apart.
Right. Okay.
Because when the nucleus gets bigger and bigger, the protons get too far away from each other. So because the strong nuclear interactions only travel a tiny distance, once the nucleus gets too big, it can't pull across the diameter of the nucleus. So that's why the atoms end up breaking apart in fission bombs. And the atoms break down into smaller atoms.
Right. Okay.
But it's that fair competition between the electromagnetic interactions and the strong interactions which cause atomic nuclei to form.
Right.
So there have to be three pairs of rules because of three pairs of leptons or three pairs of quarks. So you've got relationships which are equal and opposite. relationships which are unequal and opposite, asymmetrical, and you've got relationships which are inverse and opposite. So the relationship between matter, physical matter and space, one has physical properties, the other has no physical properties, and yet they form each other into spheres and the curvature of space.
Okay.
So again, it's that inverse and opposite relationship between matter and space. And atomic interactions are a relationship between matter and space at the electromagnetic scale, and the quantum interactions, which is based on chaos theory, which comes from the chaos of the primes. So the prime numbers are chaotic. That's why there is no formula or equation which can predict what the next one will be. Because chaos has, remember, an infinite number of possible outcomes, all unpredictable.
Right.
So the chaos of the prime numbers in the atom leads to the order of the electron shells and the order of the periodic table. That comes from the chaos of the prime numbers.
Right. Okay.
So the universe has order from chaos. And you wouldn't suspect that chaos theory would lead to order, but it does.
Ordered from chaos.
Yes. You get the order of the number systems from the chaos of the primes.
Okay. And then, so, because you also talk a bit about complexity as well.
Yes.
So where does the complexity come into this?
Right. That's very, very important. Complexity describes systems which are more ordered than the parts that make the system.
Okay.
So chaos by itself won't lead to order, but a mixture of chaos and physics leads to this paradoxical situation. So you've got some parts of the system which are completely ordered and have a single outcome. Other parts of the system are completely disordered and have an infinite number of outcomes. What comes out in between is the order of, say, a snowflake coming from water molecules. So inside a drop of water, the molecules are completely chaotic.
Right.
But the drop of water is more ordered than the molecules of water in the air. So I've gone up, I've got very, very simple symmetry in the drop of water, and that goes over to complex symmetry in the snowflakes. Okay. So complexity is systems which are not just uniform like a drop of water. A sphere.
Yeah.
And then you get drops of water, planets and stars, three kinds of spheres. The biggest sphere comes from the biggest difference between the strength of gravity and the strength of the strong interactions. The middle sphere, the planet, comes from the difference between the strength of gravity and electromagnetic interactions, which hold the Earth up. And the smallest sphere, the raindrop, comes from the smallest difference between the strong interactions and electromagnetism, which is 1/137.
Right.
And in Hilborn's book, he says that one day the two ratios, mathematical ratios which govern chaos, will sit down beside the fine structure constant, which is the difference between strong interactions and electromagnetic interactions. He predicts that they will sit down together. Now they do sit down together.
Right. Okay.
So if you look where we wrote on at the beginning, if you look for the predictions.
Yeah. Yeah, page 49 in it.
Yeah, where he says, it's hard to see that.
Is it? The structure 4.669 is destined, we believe, to take its place alongside the fine structure constant 137/1, which tells us the ratio of the strength of the electromagnetic forces to that of nuclear forces.
Yes, yeah. So that's a fabulous prediction, because now they do sit down together,
right,
side by side, because chaos is a separate set of mathematical ratios on top of classical physics and quantum physics, which provide an explanation for the self-emergence of complexity and order systems of matter.
Right.
So that's now sewn up and logical. Previous to this work, it just wasn't logical. And what people did was put chaos into classical physics. That's utter nonsense.
Right.
You can't have a pendulum which has a single number of outcomes, and you put a hinge in it, and it goes over to having an infinite number of outcomes just by one change.
No.
So Newtonian mechanics, 2 bodies in space, completely predictable.
Yeah.
3 bodies in space, completely unpredictable. Can't have that.
No.
Unless you say, as soon as you get to 3, you get another layer of behavior on top of the physics, which explains the chaotic behavior. Because the moons of Pluto, one of them is classical physics, the other 4 are all chaotic physics.
Right.
That has no explanation in Newtonian mechanics.
No.
None. So what I'm doing, explaining all this to you, is I don't end up in contradiction.
Yeah.
Those contradictions get missed by the general public because they don't have the experience to deal with them, and they don't even ask them. If I put those contradictions to a physicist, they always walk away in silence.
Right. Okay.
They never answer the question.
It's really interesting, isn't it? Though?
It is, yeah. But if I give it to somebody like you, you can see if something's logical or not, as long as I say it in the right language.
Yeah. Exactly.
So when I explain quantum entities as opposed to classical objects, you can get it.
Yeah.
One has physical properties, it has on it, and it has mathematical properties. But matter having, or energy having mathematical properties is now how it is. It has to be not a contradiction.
Right.
Because there are only mathematical properties.
Okay.
So physical properties at base are described in mathematical terms. That's a true or false question.
True.
It's true, yeah.
Right.
And if I look down inside any physical object, there are no physical entities. There are only units of energy with mathematical properties, which lead to the emergence of physical properties.
Right. Okay. So when you say about the contradictions, and you, because I'm struggling a little bit here with, because you said that the universe is built on paradoxes.
Yes.
A contradiction is a paradox, isn't it? Well, a form of a paradox.
It's a form of a paradox, but if a contradiction is something that shows why it cannot be true, so it's like an oxymoron.
Right. Okay.
But a paradox can be true because I can be both male and female at the same time.
Okay.
I cannot be alive and dead at the same time. That would be a contradiction.
Right. Okay. Yeah. So. Oh. Okay. Okay. So say that again. Paradoxes can be true.
Yes.
And contradictions show up.
Cannot be true.
Cannot be true.
No.
Okay. So, as human beings, then we are paradoxes, aren't we? That's why I find myself so confusing, and I find other human beings so confusing.
It is because your brain has a logical part and a sociological part, which is not logical at all. It has a left part of the brain, a right part of the brain. The left is logical, the right is artistic.
Right. Okay.
So it's the paradox of the way that your brain works, which makes it so interesting.
Yeah, and it's the feelings and the thoughts. It's a paradox, isn't it? It's like, you know what I mean? Feelings and thoughts. It's like, you know.
Yeah, so feelings are emotions. Emotions are the forces which push and pull the animal kingdom around. But they're not logical.
No.
They're just rules which sociological animals have to follow so they work in societies. That's it.
Right.
So that means copy any nonsense at all that you see, no matter how stupid or how cruel.
Yeah.
You just copy it.
Yeah.
Logic says it's not healthy for a society to have some members which dominate other members. So logic wins over sociological behavior, but the strength of the sociological forces always overpower logic at first.
Yeah.
That's why you tell the story of the Emperor's New Clothes.
Yes.
Logic is what you see, but that is overruled by the fact that nobody else is saying it, and it wins.
Right. So bringing this back to our previous conversation then, so we all know inherently that society is unfair.
It's both fair and unfair at the same time. We don't mind unfairness as long as it's fair. Apparently.
Right, okay.
But not contradiction.
Right.
So you want a trained pilot to fly the plane.
Yeah.
But you both have equal rights to live as human beings.
Yeah.
So you've got fairness and everybody's got equal rights. They all want to live.
Yeah.
You've got unfairness in that some people will be better at some things than others. But everybody has something which they're good at. And that has to be valued by society. And at the minute, it's not valued. Because if you're a failure at school, you're not given other options. You're just branded a failure.
Yes.
That's the painful, stupid bit.
Okay.
You have to be given other options to find out what you're good at so that you become a valuable member of society and you get a feeling of well-being within that society because you're valued, so you don't become a criminal.
Right, okay, that's interesting. Interesting.
So I'm going to see if I can contact this Professor Bruce Lipton guy.
Yeah. Yeah, I'll send you the link to his thingy as well. His the first chapter of his book.
Yes, that'd be great.
If it's only small, but it's definitely relevant to what you're saying. He seems to be really like he's forward thinking in his stuff, and he's quite he's really interested in like consciousness and stuff as well, and the great awakening and stuff.
Yeah, consciousness needs to come in layers, the same as everything else does.
Right.
Which it does. So consciousness can now be explained in the same pattern as everything else, in order of complexity.
Right, okay.
So you're conscious of yourself as an animal that wants to survive.
Yeah.
You can rise above that, is that your human level of consciousness gives you access to language and ideas which can rise above the animal behavior.
Right. Which is the high level thinking, isn't it?
Yeah, that's the high level thinking.
Right.
Which needs the evolution of language to drive the evolution of ideas, which drive the evolution of new language, which drive the evolution of new ideas.
Right. Oh, right. Okay.
So it's an iterative process.
Right. Great stuff. I think I'm going to leave it there, Peter.
We've done an hour, so we've had a really good session, haven't we, really?
Yeah, yeah. Great stuff. Yeah, I'm glad you got back in touch with me. I really thought you'd had COVID.
Well, I was off work with suspected COVID, but I had a test.
Yeah.
And I was all right.
All right. Oh, cool.
So that was good. Well, so shall we say same time next week then, Darren?
Yeah, we can. Oh, I tell you what. Do you have anything planned a bit later in the afternoon?
No.
With about 1?
No.
Is that okay? Can we make it for about 1?
Yes, sure. Next week, 1 o'clock.
Yeah, next week at 1.
Yeah, sure.
I'll try and get Richard here as well. I'll see if I can get.
Yeah, that would be good. Yeah.
Yeah, nice one.
Because when I explain things like this, it helps me to get the language right.
Well, that's it. You're in turn, like, not only am I learning, you're able to practice your skills, aren't you, Peter? And explain it.
If something doesn't work, and I know it doesn't work,
Yeah.
have another go at it.
Yeah.
Right, so we'll see you next week, Darren. That was a great session, mate.
Great stuff, Peter.
Yeah.
I love it, man. I really do.
Yeah.
And I'll send you this link now.
Fantastic. Thanks, Darren. We'll see you later.
All right, bye. Bye now.